Thank you, Paul, and thank you to our first 6 presenters. We love seeing all of your use cases. Moving into our second session, first is Eleanor with Boston University. The floor is yours, Eleanor.
Hi, my name is Eleanor Horvath. I am a senior at Boston University studying Earth observations. The research leads on this project are Rachel Brulé, who is a professor of global development policy here at BU, and Akshay Dixit, who's a PhD candidate across the river at Harvard. The power community that we're a part of is agroclimatology. Specifically, we use precipitation and temperature measurements. And I'm going to be talking about using power data to investigate the relationship between climate shocks and women's autonomy in Bangladesh. You can go ahead. So we use power data products to calculate the standardized precipitation evapotranspiration index for 90 locations that form sort of a grid or a blanket across Bangladesh. The SPEI is a multi-scalar index with respect to kind of normal climatic conditions. It takes in the temperature, precipitation, and latitude at each of those 90 locations and calculates the potential evapotranspiration. And with that, the climatic water balance. All of this is done in R, and then it's standardized into this variable. And I wanted to include those 2 graphs at the bottom of the screen that are from the SPEI documentation, not from our work. But the top is the Palmer Drought Severity Index, and the bottom is the SPEI. And as you can see, the trends are very similar across the two. I know sometimes people are a little more familiar with PDSI, but SPEI has proven itself to be also a very, very robust and reliable index for this sort of stuff. You can go to the next slide. We then use these SPEI measurements to explore the association between climate shocks and indicators of women's autonomy. So SPEI is a scale from -3, which indicates an extremely, extremely dry event, to +3, which is a really, really wet event. We use SPEI thresholds of +1.5 and -1.5. So anything from 1.5 to 3 would be an indicator of an extremely wet event. Anything from -1.5 to -3 is an indicator of an extremely dry one. We look at the climate shocks both on a female respondent's interview date, as well as the counts and types of shocks she experienced in about the 6 months preceding her interview. The socio-political variables we pull are from the Demographic and Health Surveys program, as well as some phone surveys that are completed by our team. Some of these indicators include things like, does a female respondent get the final say on household purchases, visits to family, how her own earnings are used? Are there barriers to healthcare that she experiences, including distance, a lack of transportation, or a lack of a female healthcare provider? And then other more personal or more specific questions like, does she believe domestic abuse is justified under conditions like she burnt the food or the house is untidy? Go to the next slide. Power data has enhanced our mission by giving us a set of trustworthy, continuous historical climate measurements that are undeniably the backbone of our analysis. The power record allows us to calculate these SPEI values all the way from 1981 to 2020, which helps us understand the climate norms at each of the locations. Like I said, SPEI takes in these historical weather measurements as part of their calculations, and then also helps us to quantify whether women experienced an extreme weather event in her recent history. The fun but kind of distracting animations on the bottom right there show the SPEIs that power helps us to calculate. The left are negative SPEI values, and the right are positive SPEI values on scales from 0 to -3 and 0 to +3. And these are cycling through the SPEI severities of dry and wet events during the SPEI interviews. You can go to the next slide. And then I wanted to finish by saying some of our ongoing findings. We're finding a lot of evidence that droughts actually significantly increase women's involvement in income generating work. And these effects are strengthened as the duration of the drought increases. This was a little surprising with the numbers we're running, but we're theorizing that droughts lead to significant gaps in household incomes. And in labor constrained households, this causes folks who are formerly or traditionally outside the labor force, who are usually women, to work in compensation for weather-induced drops in household income. So all in all, weather shocks can improve women's autonomy when the economic stress they cause forces labor-constrained households to support women's entry into the paid workforce. Thank you.